And I have started the recording. Okay. Typically, this is not a topic that students struggle with too much. Okay? Operations with functions. It actually means exactly what it sounds like it means. We're taking functions, we're adding them together. We're taking functions, we're subtracting them. We're taking functions, multiplying functions, and dividing them. So you're taking, so if I've got f plus g of x, you're taking all of f of x, and you are adding it to all of g of x. You are adding them together. Now, in order to be able to do this, you have to be told what f of x and g of x are. Okay? So I can have this written up here, but you can't do anything with it because I haven't told you what f of x is or what g of x is. Okay? There's a couple of things that I want you to be aware of, kind of like areas that we often make mistakes. One of them is right here. Okay? You've got to ask yourself, do I need to distribute the negative? Okay? The reason that you've got to ask yourself that is you are subtracting all of g of x. You're not just subtracting the first term of g of x. G of x can have 2 or 3 or 4 terms in it, and you're subtracting all of it. So you need to figure out if you need to distribute that negative sign, because that negative sign belongs to everything inside that g of x. So that's the first area that we have to worry about. Addition and multiplication is pretty straightforward. You add them or you multiply them. Okay? Sometimes when you're multiplying, you do have to distribute or even FOIL. So that is something that you have to do. But it's that negative sign that typically gets students. The other thing that you have to do is when we are dividing. Okay? Your denominator can't be 0. Okay, now that doesn't mean you can't plug 0 in. It means that the value of g of x can't be 0. So whenever you do g of x, you've got to figure out what values make g of x 0. And you've got to exclude those. You've got to say x can't be this number. Okay? So this is kind of the rules section right here. This is the rules section. So now we're going to do some operations with them. Is it okay if I move off this page? Okay, I think I heard a 1 second. Shay? It is, yes, most of the time. The only time that you wouldn't have to distribute the negative is if g of x was just one term. Okay? If it was just one term. So if g of x equaled x squared, all you would be subtracting is x squared. Okay? But if g of x was x squared plus 2, that's when I'd have to distribute. Because you've got to make the x squared negative and the 2 negative. Good question. Okay? Okay, now we're going to do operations with f and g. Okay? Now, f is defined. The function f is defined. It's 2x plus 1. The function g of x is defined. It's x squared plus 2x minus 1. So the first thing that I'm going to do is I'm going to add f of x and g of x together. Okay? So I have f of x plus g of x. Okay? F of x is 2x plus 1. G of x is x squared plus 2x minus 1. Okay, now I put parentheses around these so that I can clearly distinguish which one was f of x and which one's g of x. Okay, do I have anything that I need to distribute? No. Do I have anything inside the parentheses that can be combined? What can be combined inside the individual parentheses?
Oh.
No. So if I say no to those, then I can drop the parentheses. Okay? And when I drop the parentheses, it allows me to combine those things that need to be combined. Okay? So, I have 2x and 2x. That gives me 4x. Okay? Do you see that positive 1 and that negative 1? What does that give me? 0. 1 plus negative 1 is 0. And what am I left with? X squared. This right here is correct. 4x plus x squared is correct. Traditionally, you see that x squared first. Okay? That's just kind of how we write it. Mathematicians way smarter than me said, this is going to be how we write it. Okay? Now, but I don't want you to think that 4x plus x squared is wrong, because it's not. It's not incorrect. Okay. Now, we've got f of x minus g of x. And this is where that's going to come into play, this distributive. So f of x is 2x plus 1, and I am subtracting x squared plus 2x minus 1. That's the important thing to remember. We are subtracting all of g of x. All of g of x. Okay? So I have to distribute that negative to every single term in g of x. So I'm going to have 2x plus 1 minus x squared minus 2x plus 1. Okay? Here I have a 2x and a negative 2x, so those can cancel out. 1 plus 1 is what? Okay? Really complicated. Okay? And then I'm left with negative x squared. Traditionally, even though there's a negative, you're going to see it like that. Do not rewrite it as x squared minus 2. Okay? Do not rewrite it as that. Okay? Because the negative belongs to this x squared. So we're going to put it right here. We're going to put it right here. Okay? So just be aware that you got to keep that negative with the x squared. Okay. Now, we are shifting gears slightly. Instead of having f plus g of x, we've got f plus g of 3. And that's different. Okay? But don't let it trick you too much. What f plus g of 3 means is f of 3 plus g of 3. Okay? So I'm going to plug 3 in to f of x. So I get 2 times 3 plus 1. Then I am going to add that to g of 3. So I'm going to plug 3 into g of x. So I have 3 squared plus 2 times 3 minus 1. Sorry about that. The minus 1 is kind of off. Okay, and that's in parentheses. Both of those are in parentheses. So we have to fully simplify f of 3, then fully simplify g of 3. That's super important when we subtract. 2 times 3 is 6, plus 1 is 7. Okay, 3 squared is 9. 2 times 3 is 6, minus 1. Okay. 9 plus 6 is 15, minus 1 is 14. So I get 21. So F plus G of 3 is 21. Now, I want us to go back over here to F plus G of X. I want to go back over here to F plus G of X. I know that F plus G of X equals X squared plus 4X. I know that. Could I do F plus G of 3 by plugging 3 in for the X's? I could. Okay, 3 squared is 9. 4 times 3 is 12. And I get 21. Okay? Now, the plus and the minus with the numbers takes a little bit more space, so I need to erase the green on the right-hand side. Has everybody got that written down, the green on the right-hand side? Okay. So that was F plus 3, or F of 3 plus G of 3. Now, we are going to do F minus G of 2. So that is F of 2 minus G of 2. F of 2 minus G of 2. Okay? So I'm going to plug 2 in for F of X. So I have 2 times 2 plus 1. Then for G, I've got 2 squared plus 2 times 2 plus 1. It actually looks better on your screen than it does mine. Is it minus 1? Oh, I'm sorry. I was so worried about not running off the screen that I did the problem wrong. Thank you very much. Okay, now I'm going to solve all of F and all of G. So 2 times 2 is 4, plus 1 is 5. 2 squared is 4. 2 times 2 is 4. And I'm subtracting 1. So then I have 5 minus 7. 5 minus 7. Okay, and that is negative 2. Now, again, I have that F minus G of X is negative X squared plus 2. So I could go ahead and plug that in. Now, be very careful here because this negative will make people crazy. You've got to raise that negative number to the second power before you deal with that negative 1. So this is negative 1 times negative 2 squared. Okay? What's negative 2 squared? Positive 2, positive 4. It's positive 4. Negative 2 squared is positive 4. What's positive 4 times negative 1? Good. Okay? Now, the number one mistake is right here. Students see that and they're like, ooh, this is a double negative. I'm going to make that positive. This is going to be positive 2, and I'm going to square positive 2. Because they see this double negative. The problem with that, this is why that's not cool. What is happening between this negative 1 and this negative 2 squared? What's happening right here? What operation? Multiplication. What is happening here? Exponents. What comes first in order of operation? Exponents. So you have to do that first. That's when you get positive 4. Then you multiply times the negative 1. So be careful right there. Okay, are we ready to multiply and divide? Yes. Okay, here we go. Okay, we have a new f of x and a new g of x. A new f of x and a new g of x. Okay? So, we're going to do these the same way, except we're multiplying and dividing. F of x is x squared. G of x is 1 minus x. F times g. So I'm going to have f of x times g of x. Okay? F of x is x squared. G of x is 1 minus x. I have to distribute that. Okay? X squared times 1 is x squared. X squared times negative x is negative x to the third. Traditionally, you'll see that written like this. Okay? F over g of x is f of x over g of x. Okay? F of x is x squared. G of x is 1 minus x. Here's where we have to limit our domain. What is it that x cannot be?
1.
X cannot be 1. Okay? 1 minus 1 is 0. So x cannot be 1. Okay? Now, I'm going to do numbers. F times g of 4. So, what this means is f of 4 times g of 4. So I'm going to plug in 4 for x, and I'm going to have 4 squared. Then I'm going to multiply that times 1 minus 4. 4 squared is 16. 16 times negative 3 is negative 48. Now, we also know that f times g of x is equal to negative x to the third plus x squared. So I can find f times g of 4 by plugging that in. Anybody know what 4 cubed is? 4 times 4 times 4. It's 64. Okay, and then I've got a negative right there. You see the negative? So it's going to be negative 64. 4 squared is 16. So I get the same thing. Okay? F over g of 3. That's f of 3 divided by g of 3. Okay? F of 3 is 3 squared. G of 3 is 1 minus 3. So I have 9 over negative 2. Okay? This is f over g of x. So I can do f over g of 3, and I have 3 squared, 1 minus 3, and that's 9 over negative 2. Okay? So either method is completely fine. Either method there is fine. Sometimes I do both methods just to make sure I'm right. Okay? Okay. We have a little bit more time, and we're going to talk about composition of functions. So typically, students do completely fine with operations of functions. Then we get into composition of functions, and they're like, I'm going to need another day. Okay? And that's what happens. So I want to spend these last 12 minutes showing you how to do composition of functions, so then on Thursday we can practice them. Okay? So we can practice them again. So, here is composition of functions. In high school, you probably called them Fogg and Goff. Sometimes I have students come up to me and say, Alicia, are we going to do Goff? Are we going to do Fogg? I'm like, we're going to do composition of functions, yes. So it's not Fogg and Goff. The way that you read this as F composed of G of X. That's how you read it. F composed of G of X. So what you do with that is you're going to take the function G of X and you're going to plug it into F of X. Okay? And we'll actually do that in just a couple minutes. Okay? You can also have a G composed of F of X, and you would read that as G composed of F of X. Okay? G composed of F of X. Okay, can I go to the next screen? I see a couple people writing. I'll wait just another second. Okay, again, you have to be given F of X and G of X. You can't do this if you're not told what F of X and G of X is. Okay, so here, I am told that F of X is X plus 2, and I am told that G of X is 4 minus X squared. The first one is F composed of G of X. Some students like to think of it as F of G of X. So I would take whatever G is, and then I would plug it in for what X is in F of X. So I am taking this right here, and I am plugging it in for that X right there. Okay? That's what I'm doing. So I'm going to have X plus 2. And where that X is, I'm going to put 4 minus X squared. And then I am adding 2 to it. Okay? Now I can drop the parentheses. Four plus 2 is 6. So I get negative X squared plus 6. Okay? So I started, like F of X is what I was using. I had X plus 2. Then I took my G of X and plugged it in for the X in F of X. So I take G and plug it into F. I take G and plug it into F. Here we're going to do the opposite. I'm going to take F and I'm going to plug it into G. So I am taking this value and I am plugging it in for that X right there. That's what I'm doing. I'm taking X plus 2 and I'm going to plug it in for the X in G of X. Okay? So for G composed of F, I have 4 minus x squared. So I am replacing the red x. That's what I'm replacing. So I have 4 minus x plus 2 squared. Okay? So I took f of x and I put it into g of x. G composed of f. Now, what do I have to do first here? What do I have to do first? I have to multiply x plus 2 times x plus 2. And how do I do that? FOIL. Okay, so be careful with that. Some students like to distribute that negative first, and you can't. We are going to have to distribute the negative, but not yet. X times x is x squared. X times 2 is 2x. 2 times x, 2 times 2. So I have x squared plus 4x plus 4. So 4 minus x squared plus 4x plus 4. Okay? What do I need to do next? Who does that negative belong to? Everything. Okay? So I've got to distribute that negative. So I have 4 minus x squared minus 4x minus 4. I have a positive 4 and a negative 4. I'm left with negative x squared minus 4x. That is G composed of F. Okay, now I want you to look over here to what I've got for my last one. I've got G composed of F of negative 2. This is a two-step process. Okay, this is a two-step process. The first thing that you are going to do is you are going to find f of negative 2. Okay? You're going to find f of negative 2. Whatever f of a negative 2 is, you're going to find it. Okay? Then the second step, plug value from step 1 into g of x. Okay? So, f of x, I'm going to plug negative 2 in. So when I do f of negative 2, what do I get? 0. Okay, so f of negative 2 is 0. Now, so this is step 1. Step 2, I'm going to take that 0 and plug it into g of x. So I'm going to have g of 0. Okay, so what is that? What's 4 minus 0 squared? Did you say 4? Yeah, it's 4. Good job. Okay? Now, this is g composed of f of negative 2. Is this right here g composed of f of x? Yeah, so I could stick that negative 2 in there if I wanted to. So I'm going to have negative 2 squared minus 4 times negative 2. So we got a whole bunch of negative signs. Order of operations says I have to do what first? I've got to do that exponent first. If you don't do the exponent first, you're going to mess up. Negative 2 squared is positive 4. But I still have that negative. So I have negative 4. What's minus 4 times negative 2? Positive 8. Okay, do I get the same thing? I do. I do. Okay, don't be nervous if composition of functions is a little hazy. It takes some practice. Okay, on Thursday,